There are numerous structural systems that can be adopted in building structures. We are already familiar with beam and slab systems, which are the most commonly used structural systems. A beam and slab system are one of the easiest load transfer systems in terms of structural performance as well as easiness of design. The decision of the type of structural system to be used in a building is not just a structural decision these days. There are also many construction related and economy related reasons as well. Many times, architectural reasons also decide the structural system. Now we have an idea about structural system. Let's start by asking this question. What is a flat slab? Flat slab is a type of floor construction that is frequently used in modern buildings. It can also be referred to as the flat floor, concrete flat sheet, or flat plate. Basically, it is a floor without a frame in the building. To explain it a bit more, a flat slab construction is where the slab directly rests on columns without beams. If there is no drop at the column and slab meeting point, it is called flat plate, and if there is a drop, it is called a flat slab. Flat plates are possible when the space of the columns is less. If the span are larger, then punching may become critical and a drop may be needed. Flat plates are generally preferred in smaller housing and apartment projects. Flat slab with drop panels are used for office buildings, shopping complexes, and malls in most parts of the world. Reducing the height of the building. Flat slab reduces the total height required for each floor of the building. This allows to accommodate a greater number of floors in a building for a given height. Many times, the height of the building will have a restriction in a given location. An example is a building near an airport. The building regulatory authority would have limited the maximum allowable height in the flight path. So, without flat slab, adopting a beam and slab system increases the floor height because of the depth of the beam. This reduces the number of floors possible to be built in a given height, and the builder will lose a floor to sell. If there are multiple blocks in a project, you can imagine the profit a builder can make by selling more if he adopts a flat slab system. Avoiding sleeves through beams. By adopting flat slab system, we can avoid sleeve passing through the beams. Many times, the builder will like to keep the floor height less, as I have mentioned earlier. If services like electrical or plumbing need to pass pipes, it has to cross through beams. If we take it under the beams, the floor clear height will reduce and will not be okay in functional point of view. But with flat slab system, we don't need to worry about the sleeve passing through the beams. More daylight in the building. Beams are hindrance to light and air movement in a building structure. A beamless construction will allow more uniform lighting inside the building. Also, more airflow in the building without any hindrance is possible with beamless design. Flat slab is a beamless construction and is useful for having better daylight and air movement. Architects and clients would love to have this system, although it might not be the same for structural engineers. Easy reinforcement placement. The rebar reinforcement in a flat slab is simpler compared to conventional slab beam system. Then finally, faster construction. Since it is easier to install the formworks and the reinforcement in flat slab system, the flat slab construction can be faster than conventional beam and slab because the workers don't need to worry about the beam construction. The major disadvantages of flat slab and any beamless system like flat plate is a lack of resistance to lateral load such as wind load and seismic or earthquake forces. Due to this, we may have to adopt a single system where the entire lateral forces are dumped into the shear walls. Because of the higher challenges due to this, it is not recommended to use flat slab system in high-rise construction or in regions always prone to earthquake. Generally, a flat slab should be designed for bending moment, shear forces, and the punching shear. In modern and large buildings, it is recommended to use analysis software like ETABS for the structural analysis. You can calculate the forces in ETABS and design it manually by a few quick steps or use a strip method of design. The same strip method of design is also available in CSI Safe, which is owned by CSI America. So, although flat slab is a great structural system with respect to its aesthetics and functional use, it needs to be carefully chosen only in non-seismic zones. In most parts of the world, it shall be used only in non-seismic zone as much as possible and not in higher zones. If you ever choose to use flat slab, it needs a careful attention in the scheme in order to take care of the lateral load transfer. If you have any structural questions on flat slab design using ETABS, leave a comment below. Also, like and share this video for a better reach to other civil engineers and structural engineers. Thank you. Before you leave, you can hit the red subscribe button to subscribe to this channel in a tutorial for more construction videos like this. With that being said, you all have a good and a wonderful day. God bless you all. Bye bye.